So, we've got the Hoffman's voltammeter up and running. You should be able to see from the film that I'm taking at the moment that you've got bubbles of gas forming around these platinum electrodes. Now, the electrode on the left-hand side has a black wire going into it, and that one is connected to the negative, which means it's the cathode. The electrode with the red wire attached to the bottom there is connected to the positive, and that makes that electrode the anode. And I'm just going to move in a little bit so that we can actually see this a little bit more clearly. What you should be able to see in the film is that we've got quite a large bubbles coming off the black negative electrode. Now, what gas are we expecting at the negative electrode here? Hydrogen. Okay, so that's correct. If you actually look, I'm not going to move the position of the camera at the moment, but if you actually look towards the top there, you can see that you've got approximately twice the volume of hydrogen as you have oxygen. So we've still got, the gas coming off of the positive electrode is oxygen. So there's a combination of reactions going on, but the ones that you really need to look up are, for the cathode reaction is probably a combination of the water cathode reaction that produces hydrogen, and also because we've got, this is quite concentrated sulfuric acid in here, it's 0.5 m approximately, you could also consider the 2H plus 2 electrons going to hydrogen being involved as well. So it's a combination of both. But what you have to remember in every case with electrolysis is what type of reaction occurs at the cathode. Reduction. It's always a gain of electrons. So you must remember that for the exam, that during electrolysis you get reduction of the cathode, which means you get oxidation of the anode. Now the reaction happening at the anode is just the water reaction producing oxygen and 4H plus, I think, plus 4 electrons. Sulfate is never involved in any kind of redox reaction. So even though the sulfate anion is present in this mix, it doesn't actually take part in the reaction. Platinum electrodes are used in the Hoffman's voltammeter because platinum is not in any way affected by the dilute sulfuric acid. It's completely inert. We could use that for 100 years and it'd stay the same. Okay? As long as the equipment doesn't deteriorate. Obviously, you'd have to replace the rubber bungs in that time, but the platinum should remain. Notice the reservoir, which holds the sulfuric acid. As gas bubbles are being produced here, the level of the acid is rising up in the reservoir here. And now, if that fills all the way, this will actually be quite high at the end. Hopefully it won't overflow, but okay. Now, normally what I would do if I'm testing this, I would go in stages, but I want to try and hit it all in one go today. I would normally collect a test tube worth of hydrogen above the cathode and do a hydrogen test. How do you actually test for hydrogen? You use and what happens? You just get a sort of a squeaky pop type thing. How do you test for oxygen gas? And just for oxygen? What kind of splint? Not, well, you could use it and you might see something, but a standard test for oxygen is one that's just been blown out. What happens if you place it inside oxygen? It'll relight. Okay. Now the other thing that's worth noting here, and I don't know how successful we're going to be, but we've added methyl orange to this. Now the methyl orange has gone red because it's in acid, but the problem is here, I think we've actually got quite a high concentration of sulfuric acid. So whatever hydroxide is being produced at the cathode is going to be simply converted to water. There's going to be far too much H plus for you to see this solution become yellow in the middle there. I might be wrong. By the end of it, we might get some evidence of a yellow or an orange solution around that cathode, but it's probably unlikely with the amount of H plus. Okay, do I need to say anything else about this at the moment? No, I'm not. So I'm going to stop this film now. This is part 1, and I'll refilm for part 2.